So good afternoon everyone. I am your teacher for today's video. So I am teacher Nessa and today we are going to tackle annihilating polynomials. So what is annihilating polynomials? It is typically referred to finding another polynomial that evaluates to zero when applied to a given polynomial. It's often used in the context of linear algebra and field theory. So, how to annihilate polynomials? Okay, so here, to annihilate the polynomials, you can find another polynomial called the annihilator, which when applied to the given polynomial results in zero. So the process of this depends on the specific context or the problem you're dealing with. So here is the definition of annihilating polynomial. Let T be a linear operator of a finite dimensional vector space V over the field F. So the minimal polynomial for T is the unique or the monic generator of the ideal of polynomials over F, which annihilate our T. So I have here an example. So let T colon R cube approaching R cube be the linear operator defined by the matrix of T. So in annihilating polynomials, you need to find the characteristic and minimal polynomials. So in calculating the characteristic polynomial, we are going to calculate the depth of T minus lambda I is equal to 0. So in our characteristic polynomials, it is always equal to 0. So this gives you the characteristic polynomials, which is lambda minus 1 times lambda minus 3 and lambda minus 2. So now, saan ba natin nakuha yung negative 1, negative 3, and negative 2? So dito natin yun nakuha sa ating matrix, which is 1, 3, and 2. So, isa-substitute lang natin siya sa ating formula in finding the characteristic polynomial. So, ito na yung characteristic polynomial natin. So, next, we are going to find the minimal polynomial. So, in finding our minimal polynomials, we need to factorize the characteristic polynomial and the minimal polynomial. So, the minimal polynomials for T is So, kung nagtataka kayo kung bakit the same lang yung answer ng characteristic at ang minimal polynomials natin, it is because when factoring the characteristic and the minimal polynomials, we are using irreducible factorization. So, when we say irreducible factorization, it is a result that they cannot be reduced into factors containing only real numbers. So, that is the irreducible factorization. So, yun yung ginamit natin dito sa characteristic and minimal polynomials natin. Okay, so let's proceed to another theory. So, let T be a linear operator in a finite dimensional vector space V if F is the characteristic polynomials of T, then F of T is equal to 0. So in other words, the minimal polynomials divides the characteristic polynomials of our T. So in doing that, let's break down the relationship between the characteristic polynomial and the minimal polynomial for a linear operator T on the finite dimensional vector space V. So this means that in the characteristic polynomial of f of t colon, so the characteristic polynomial of f of t is obtained by taking the determinant of t minus t times I, where I is the identity operator and t is a variable. So the roots of our f of t are precisely the eigenvalues of our t. So sa minimal polynomials naman, if our t is the smallest degree monic polynomials, that when applied to t gives the zero transformation. So ganyan lang yung monic polynomials natin. So it has the property that it evaluates to zero when applied to t, meaning that if f of t is equal to 0. So para maintindihan yung relationship ng dalawa, so if our f of t is the characteristic polynomial of our t, then f is t is equal to 0. So in other words, when you replace t in the t here, the big T here, with the operator t, the result is the zero transformation. So this one. So this means that the minimal polynomial of t divides the characteristic of polynomial f of t. So sa mathematical terms naman, if yung m of t natin is the minimal polynomial and the f of t naman natin is the characteristic polynomial. So may mag-exist na another polynomial which is the g of t, such that f of t is equal to t times g of t. So ito yung magiging exist na another polynomials. So for you to really understand what is mean, I have another example. So we have here, let t colon r squared approaching r squared be the linear operator defined by the matrix of our t. So in finding the characteristic polynomial of f of t, the characteristic polynomial of f of t is, we are using the formula of the characteristic polynomial, which is that of t of I natin. So in solving the characteristic polynomial, isa-substitute lang natin ito. So since our t here in our matrix, so we have the yung numbers na napaulit-ulit, which is 2. So nakikita niyo naman na 2 yung numbers na paulit-ulit. So 2 minus t of squared. So squared na siya dahil dalawa yung 2 natin sa ating matrix. So ito na yung magiging characteristic polynomials natin. So sa minimal polynomial naman natin, since ang minimal polynomial natin is f of the big letter of our t is equal to 2 minus t squared. So yan yung minimal polynomial natin. So may kulang dito. Ano yung kulang dito? So it is equal to 0. So the minimal polynomial is the m of t is equal to 2t. So ang minimal polynomial natin is m of t is equal to 2 minus t. So yan yung minimal polynomial natin. So in this example, the minimal polynomial of our m of t divides the characteristic polynomial of our f of t. So as you can see here, diba? So, the f of t is equal to 0. So, makikita natin ang relationship holds for any linear operator and its corresponding polynomial. So, it's not very difficult since you have to substitute the given matrix of the equation. So, the symbol lambda here, yung reverse y, it is called a lambda. So, in the context of mathematics and the various scientific fields, it is often used as a representative of a variable or parameter or either eigenvalue. So, in Greek alphabet naman, yung lambda correspond to the letter L. So, this is all about my report about annihilating polynomials. So, thank you for watching and goodbye.